So here's the problem in 1943. American bombers are getting slaughtered over Germany. Like absolute carnage. We're not talking about a few planes here and there. We're talking about entire formations getting ripped apart in broad daylight, crews burning alive at 25,000 feet, and generals back home watching their grand strategy crumble in real time. The 8th Air Force, stationed in England, had this beautiful theory called daylight precision bombing. The idea was simple and, on paper, made perfect sense. Instead of bombing cities at night, like the British, who couldn't hit specific targets in the dark and just carpet-bombed everything, the Americans would fly during the day, use their fancy Norden bomb sites, and surgically destroy German factories, oil refineries, and ball-bearing plants. Take out the production, and you starve the Nazi war machine. Clean, efficient, American. Except reality had other plans. The Germans weren't idiots. They saw these massive formations of B-17 flying fortresses and B-24 liberators crawling across the sky at 180 miles per hour, and they built an absolutely murderous air defense system to deal with them. Thousands of anti-aircraft guns, hundreds of Messerschmitt Bf-109s and Focke-Wulf FW-190s. Experienced pilots who've been fighting since Spain, Poland, France, and the Eastern Front. The Luftwaffe was no joke. And here's the thing about bombers. They're big, slow, and packed with fuel and explosives. They fly in tight formations for mutual protection, bristling with defensive guns, but a determined fighter attack could shred them. German pilots developed tactics specifically designed to break up American formations. They'd come in head-on at closing speeds of 500 miles per hour, firing cannons and machine guns, then barrel roll through the formation before the gunners could track them. They'd target the lead aircraft first because knocking out the lead bombardier meant the whole formations. Bombing accuracy went to hell. They'd hit the stragglers. Any bomber that fell out of formation due to mechanical problems or damage was basically dead. Imagine being that crew. Your number 2 engine is smoking. You're losing altitude. You watch your formation pull ahead, and you absolutely know that fighters are circling, waiting for you to fall just far enough behind. Now, the Americans weren't sending these bombers alone. They had fighter escorts. The P-47 Thunderbolt was a beast 8.50 caliber machine guns, a massive radial engine, and armor plating that could take a beating. Pilots loved it. The problem? Range. The P-47 could escort bombers for maybe 175 miles into Europe before it had to turn around or risk running out of fuel and ditching in the English Channel. Same with the Spitfire, beautiful plane, legendary in the Battle of Britain, but its legs were even shorter. So here's what happened on a typical mission in 1943. Bombers form up over England. Fighters join them. They cross the Channel together. They push into France. And then, somewhere around the German border, the fighters waggle their wings, peel off, and head home. The bomber crews wave goodbye to their little friends and press on alone, deep into Germany, where the Luftwaffe is waiting. It's hard to overstate how terrifying this was. You're a 22-year-old ball turret gunner from Ohio, crammed into a glass sphere under the belly of a B-17, watching friendly fighters disappear into the distance, knowing that for the next several hours, you're on your own. The Germans timed their attacks precisely. They knew the range limitations of American escorts. They'd let the fighters leave, wait a few minutes to make sure they weren't coming back, and then launch massive coordinated assaults. 50, 60, sometimes 100 fighters swarming a bomber formation. The carnage was indescribable. On August 17, 1943, the 8th Air Force launched the famous Schweinfurt-Regensburg mission, a double strike against ball-bearing factories and aircraft plants deep in Germany. Out of 376 bombers, 60 were shot down, and 87 were damaged beyond repair. That's 600 men killed or captured in a single day, and they didn't even destroy the targets. The factories were back in production within weeks. A month later, they tried again. Black Thursday, October 14, 1943. Another raid on Schweinfurt. This time, 291 bombers went in. 77 were shot down. 121 were damaged. Casualties approached 650 men. The 8th Air Force lost so many aircraft that they had to suspend deep penetration missions into Germany for months. The daylight bombing campaign was dying, not because the theory was wrong, but because they couldn't protect the bombers. This is where the fuel tank problem becomes critical. Everyone knew the solution: get fighters who could go the distance. Escort bombers all the way to the target and back. But building a long-range fighter isn't as simple as slapping a bigger gas tank on a plane. Physics doesn't care about your war strategy. It cares about weight, drag, and aerodynamics. A fighter's performance depends on its power-to-weight ratio and its wing loading. Add more fuel, and you add weight. Add weight, and suddenly your nimble dogfighter handles like a dump truck. German pilots in Bf-109s would eat you alive. Plus, internal fuel tanks take up space. The P-47 already had a big fuel tank, but it also had a massive turbo supercharger and other equipment stuffed into the fuselage. You couldn't just magic more capacity into existence. The airframe had limits. Same with the P-38 Lightning, a twin-engine fighter that had decent range, but was complex, expensive, and had performance issues at high altitude in cold European weather. The engines ran rough. The cockpit heating was inadequate. Pilots were freezing while their controls stiffened. It wasn't working. The P-51 Mustang existed by this point, but the early versions had a different problem. The original P-51 used an Allison V1710 engine that performed well at low altitude, but fell off badly above 15,000 feet. And bombers flew at 25,000 feet. You can't escort bombers if you're gasping for air 5,000 feet below them. The Mustang needed a new engine. Enter the British. Specifically, Rolls-Royce and its legendary Merlin engine. The same engine that powered Spitfires and Hurricanes during the Battle of Britain. Someone and historians still argue about who deserves the credit for having the brilliant idea of stuffing a Merlin into a P-51 airframe. The combination was magical. The Merlin had a two-stage, two-speed supercharger that maintained power at high altitude. Suddenly, the Mustang could climb, fight, and maneuver at 30,000 feet just as well as at sea level. And because the P-51 had a laminar flow wing, a revolutionary design that reduced drag, it was faster and more fuel efficient than almost anything else in the sky. The P-51B and P-51D variants with Merlin engines became arguably the best piston engine fighters ever built. Fast, maneuverable, deadly, but they still had a range problem. Even with Merlin's fuel efficiency, internal tanks alone weren't enough to escort bombers to Berlin. And Berlin was the ultimate target, the heart of the Reich. Taking the fight to the enemy capital wasn't just strategic, it was psychological. It would prove that Germany couldn't protect its own homeland, so they needed more fuel capacity. And internal space was maxed out. The answer? External tanks. Drop tanks weren't a new concept. The idea had been around since the 1920s. Strap an extra fuel tank to the outside of the aircraft under the wings or the fuselage. The fighter uses that fuel first, drains the tank, and then jettisons it before combat. You enter the fight with a full internal tank and a clean airframe. Best of both worlds. But there was a problem. Drop tanks were made of metal, aluminum or steel, depending on the design. And in 1943, America had a massive aluminum shortage. Every pound of aluminum was precious. Bombers needed it. Fighters needed it. Ships, trucks, jeeps, radios, everything needed aluminum. The military-industrial complex was churning out war material at an insane rate, but demand always outstripped supply. So here's the absurd situation. America has the solution to its escort problem, external fuel tanks, but can't build enough of them because the material is being used to build the planes that need the tanks. It's a resource bottleneck wrapped in an irony wrapped in a tragedy. Thousands of bomber crewmen are dying because America doesn't have enough metal to make throwaway fuel cans. Now, this is where it gets interesting. Somebody looked at this problem and had an absolutely wild idea. What if we didn't use metal at all? What if we made drop tanks out of something America had plenty of? Something cheap, lightweight, and readily available? What if we made them out of paper? Yeah, paper. Pressed, laminated, resin-treated paper. The concept sounds ridiculous, and when it was first proposed, everyone treated it that way. Military engineers were skeptical, bordering on hostile. Aviation fuel is not something you mess around with. It's volatile, corrosive, and extremely flammable. The idea of storing it in what amounted to glorified cardboard seemed suicidal. Paper absorbs moisture. Paper tears. Paper burns. How could paper possibly hold 75 or 100 gallons of high-octane aviation fuel under the stress of combat operations? How could it withstand the cold at 25,000 feet? The vibrations of a 1,500 horsepower engine, the aerodynamic forces of 400-mile-per-hour flight, the sudden release and tumbling fall when jettisoned? Every instinct said this was impossible. But here's what the skeptics didn't understand. This wasn't ordinary paper. The tanks were made using a process that transformed paper into something far stronger than its raw form. Multiple layers of paper were laminated together using phenolic resins, essentially early plastics derived from phenol and formaldehyde. The layers were pressed under heat and pressure, creating a composite material that was lightweight, waterproof, and surprisingly rigid. Think of it like plywood, but made with paper instead of wood veneers. Or like the material used in old-school Bakelite products, telephones, radios, and electrical insulators. It was called impregnated paper, or sometimes paper composition. The manufacturing process was well understood from other industries, but nobody had thought to apply it to aircraft fuel tanks. The key insights were these. First, the phenolic resin completely sealed the paper fibers, making the material impervious to fuel. Aviation gasoline couldn't soak through or degrade it. Second, the laminated structure distributed stress across multiple layers, giving the tank's structural integrity far beyond what single-layer paper could achieve. Third, paper composite was naturally insulating. It didn't conduct heat as readily as metal, which actually helped maintain fuel temperature stability. Fourth, and perhaps most importantly, paper doesn't spark. One of the big fears with metal tanks was that bullet impacts could create sparks that would ignite fuel vapors. Paper composite was much safer in this regard. A bullet would punch through, sure, but without the metal-on-metal friction that creates ignition sources. The production advantages were enormous. The paper was cheap. Paper was abundant. American paper mills were running at full capacity, but they weren't constrained by the same raw material shortages affecting metal production. Wood pulp came from forests, and America had plenty of forests. The industrial infrastructure for paper manufacturing was mature and distributed across the country. Converting paper mills to produce fuel tank components didn't require the specialized equipment or rare alloys that metal tank production demanded. You could theoretically spin up paper tank production faster and at more locations than metal tank production. Plus, the tanks were lighter. A paper drop tank weighed less than its aluminum equivalent, which meant the aircraft could carry more fuel for the same weight penalty or carry the same fuel with less drag and better performance. Every pound matters when you're trying to maximize range. And unlike aluminum tanks, paper tanks weren't competing with critical aircraft construction. Every paper tank produced was one aluminum tank not built, which freed up that aluminum for another P-51 wing or another B-17 fuselage. The resource math worked out beautifully. But logic doesn't always overcome institutional resistance. The military establishment was conservative by nature and with good reason. In aviation, untested innovations kill people. The engineers who pushed back against paper tanks weren't being stupid. They were being cautious with pilots' lives. They'd seen too many brilliant ideas fail catastrophically in the field. Paper fuel tanks sounded like exactly the kind of shortcut that gets young men killed. So the paper tank advocates had to prove their case with evidence, not just arguments. Testing began. Rigorous, exhaustive testing. They filled paper tanks with fuel and let them sit for days to check for leaks and degradation. They subjected them to vibration tests, simulating engine harmonics. They froze them to simulate high-altitude temperatures. They dropped them from towers to simulate jettison impacts. They shot them with bullets to see how they'd fail. They flew them on test aircraft in every conceivable condition. and the tanks held up. Not perfectly, early designs had issues that required refinement. The resin formulations were tweaked. The lamination process was standardized. The tank shapes were optimized for aerodynamic release. Fittings and attachment points were redesigned to ensure clean separation. But with each iteration, the paper tanks got better. By late 1943 and early 1944, they were ready for combat deployment. The timing couldn't have been better. The 8th Air Force had a new commander, General Jimmy Doolittle. Yes, that Doolittle, the guy who led the famous Tokyo raid in 1942, launching B-25 bombers off an aircraft carrier to strike the Japanese homeland 4 months after Pearl Harbor. Doolittle was a calculated risk-taker and an aviation genius with a PhD in aeronautical engineering from MIT. He understood the technical and tactical dimensions of air warfare better than almost anyone alive, and he immediately grasped what the fighter range problem was costing the bomber offensive. More importantly, he changed the doctrine. Previous commanders had instructed fighters to stay close to the bombers, flying tight escort patterns even when German fighters weren't actively attacking. This was defensive and reactive. Doolittle flipped the script. He told his fighter pilots, "Go hunting. Don't wait for the Germans to attack the bombers. Go find them. Chase them. Destroy them on the ground if you have to. Make the Luftwaffe bleed." This offensive posture transformed the air war, but it required fighters with the range to roam deep into Germany, far from the bomber streams. It required drop tanks, lots of them, and paper tanks were now available in quantity. The P-51 Mustang became the primary delivery vehicle for this revolution. Equipped with a Merlin engine and carrying 2 75-gallon paper drop tanks under its wings, the Mustang could escort bombers from England to Berlin and back. That's over 1,800 miles round trip. No fighter had ever done that before. And the Mustang wasn't just reaching Berlin, it was arriving with enough fuel to fight. Pilots would burn the drop tank fuel during the cruise to the target, jettison the empty tanks before combat, and engage German interceptors with full internal tanks. They had the fuel for extended dogfights, for chasing fleeing enemies, for making multiple attack passes. The psychological impact on German pilots was devastating. Before the Mustang, attacking American bomber formations was dangerous but manageable. You'd wait for the escorts to leave, swoop in, make your kills, and break off before the bomber's defensive fire got you. After the Mustang, there was no safe window. Those damned American fighters just kept coming. They'd follow you back to your airfield and strafe you on a runway. They'd hunt you through the clouds. They'd be waiting when you took off and when you tried to land. One German pilot described it as fighting ghost enemies who appeared from nowhere and seemed to have unlimited range. The statistics tell the story. In January 1944, before the long-range escorts became fully operational, the 8th Air Force lost nearly 9% of bombers on deep penetration missions, meaning almost 1 in 10 aircraft didn't come back. That loss rate was unsustainable. You'd burn through your entire bomber force in a few months. By June 1944, after the Mustangs with drop tanks had established air superiority, losses dropped below 2%. That's a 4-fold improvement in survival rates, achieved not by any change in bomber tactics or defensive armament, but purely by the presence of fighters that could go the distance. And the Luftwaffe was bleeding out. In what became known as Big Week, February 20th to 25th, 1944, the Allies launched coordinated maximum effort raids against German aircraft factories. The goal was to force the Luftwaffe to defend these critical targets and then destroy their fighters in the air. Over 6 days, nearly 4,000 bomber sorties and 3,700 fighter sorties struck aviation plants across Germany. The bombers took losses, but the escorts extracted a terrible toll. Germany lost approximately 355 fighter aircraft, about 20% of their single-engine fighter strength, in less than a week. More critically, they lost experienced pilots. Aircraft can be replaced, veteran pilots cannot. The Luftwaffe was being hollowed out. The pilot training program couldn't keep pace with losses. New pilots were being rushed to frontline units with barely 100 hours of flight time, facing American pilots with 300 or 400 hours. It was a slaughter. By the time D-Day arrived on June 6, 1944, Allied air supremacy over Western Europe was total. The Luftwaffe barely appeared over the Normandy beaches. Years of attrition, culminating in the long-range escort campaign, had broken the German Air Force as an offensive instrument. And the humble paper drop tank was a crucial piece of that victory. That let's zoom out for a moment and appreciate the beautiful absurdity of this. History's most destructive air campaign was enabled by cardboard. The machine that conquered the skies of Europe, the P-51 Mustang, a 37-foot metal predator with a 1,695 horsepower engine and 6.50 caliber machine guns, depended on tanks made from pressed paper. Engineers said it was impossible. They said it would fail. They said you were going to kill pilots with your harebrained paper scheme. And they were wrong. Not because they were stupid, but because innovation often looks stupid right up until the moment it works. The history of technology is littered with ideas that experts dismissed as impractical, impossible, or insane. Heavier-than-air flight was impossible until the Wright brothers flew at Kitty Hawk. Rockets in space were impossible until Goddard and von Braun proved otherwise. And paper fuel tanks were impossible until they flew thousands of combat missions and helped destroy over 5,000 German aircraft. The lesson here isn't that experts are always wrong. Most expert skepticism is well-founded. Most crazy ideas really are crazy. But sometimes, just sometimes, the crazy idea is exactly what the situation demands. And having the courage to pursue it, to test it rigorously despite mockery, to refine it until it works, is what separates incremental progress from breakthrough innovation. Now, let's talk about the Mustang itself, because the plane and the tanks formed a synergistic system, each enabling the other's success. The P-51 didn't start as the war-winning weapon it became. Its origin story is actually kind of bizarre. In 1940, the British Purchasing Commission approached North American Aviation, an American aircraft company, and asked them to build P-40 Warhawks under license. The P-40 was the main American fighter at the time, decent but not spectacular. North America's president, James Dutch Kindleberger, made a counterproposal. Give us 120 days, and we'll design you a better plane from scratch. The British, desperate for aircraft as the Battle of Britain raged, agreed. North American delivered the prototype NA-73X in just 102 days. It was a remarkable feat of rapid engineering. The new plane incorporated several innovative features, including a laminar flow wing designed to minimize drag at high speeds. But the Allison engine limited its high-altitude performance, so the British initially used their Mustang Mk for low-level reconnaissance and ground attack rather than bomber escort. The transformation came when Rolls-Royce engineers, recognizing the airframe's potential, married it to the Merlin engine. The Mustang Mk3, equivalent to the American P-51B, first flew with a Merlin in late 1942. Performance was spectacular. The plane exceeded 440 miles per hour at altitude, faster than any contemporary American or British fighter. The range with internal fuel alone was approximately 750 miles, already impressive, but with drop tanks, it could exceed 1,650 miles. By comparison, the P-47 had an internal range of about 640 miles and could reach perhaps 1,250 miles with tanks. The P-38 could manage around 1,100 miles with tanks, but had those altitude performance issues. The P-51D, which became the definitive wartime variant, incorporated further refinements. A bubble canopy for better visibility, improved aileron control at high speed, an additional .50 caliber gun per wing for a total of 6, and increased internal fuel capacity. It was the complete package. Fast, maneuverable, well-armed, and long-legged. Pilots adored it. Chuck Yeager, who would later become the first human to break the sound barrier, scored most of his 11.5 aerial victories in AP-51D named Glamorous Glennis after his wife. He once shot down 5 German aircraft in a single mission. George Preddy, the top Mustang ace with 26.83 victories, described the plane as a joy to fly, responsive, forgiving, and lethal. The Mustang's arrival fundamentally altered the calculus of the air war. Before, German pilots could be confident of local superiority. They knew the range limitations of Allied fighters and planned accordingly. After the Mustang achieved critical mass in early 1944, that confidence evaporated. American fighters appeared everywhere, seemingly without range limits. They strafed airfields. They hunted trains. They shot up anything with German markings. The Luftwaffe was forced into a reactive, defensive posture from which it never recovered. But all of this, every kill, every mission, every save bomber depended on those extra gallons of fuel. Hanging under the wings. Without drop tanks, the Mustang's 750-mile internal range fell short of Berlin by hundreds of miles. The plane would have been relegated to medium-range escort duty, overlapping with the P-47, while bombers continued to die over Germany. With drop tanks, it became the longest-ranging single-engine fighter of the war. And paper tanks ensured that drop tanks could be produced in sufficient quantity without cannibalizing other war production. The numbers are staggering when you look at total production. By the end of the war, hundreds of thousands of drop tanks have been manufactured. Not all paper metal tanks continued to be produced as supply constraints eased, but paper tanks filled a critical gap during the period when the air superiority campaign was being won. They were the ugly, unglamorous, disposable component that made the glamorous victories possible. Let's talk about what destroying 5,000 German planes actually means, because that number deserves unpacking. The claim refers specifically to aerial victories enemy aircraft shot down in air-to-air combat credited to P-51 Mustang pilots during World War II. This count comes from official use-off records and represents confirmed kills where gun camera footage or witness testimony verified the destruction of an enemy aircraft. Different sources give slightly different figures due to variations in how claims were adjudicated, but 5,000 is a reasonable midpoint estimate that appears in many historical accounts. To put this in perspective, Germany produced approximately 119,000 aircraft during the war. About 50,000 of those were fighters. The Mustang, by itself, destroyed roughly 10% of all German fighters ever built. And that's just air-to-air kills. It doesn't include aircraft destroyed on the ground during strafing attacks, which would add thousands more. It doesn't include aircraft so badly damaged that they were written off after landing. It doesn't include pilots killed or wounded who would never fly again. The Mustang's actual contribution to attriting the Luftwaffe was substantially higher than the 5,000 figure suggests. Now, here's a nuance that often gets lost. The paper fuel tanks didn't directly destroy those planes. The tanks were jettisoned before combat. They were empty husks tumbling through European skies, crashing into forests and fields, occasionally bonking a German farmer on the head. What the tanks did was enable the conditions under which those kills became possible. They extended the Mustang's reach. They allowed pilots to enter combat with full internal fuel. They gave commanders the flexibility to assign escorts to the deepest targets. Without the tanks, the kills don't happen because the Mustang couldn't shoot, but because it couldn't get there. This is a useful distinction because it illustrates how complex systems win wars. Victory rarely comes from a single wonder weapon. It comes from the integration of many components, some glamorous, like the P-51 airframe, some mundane, like the paper drop tank, some invisible, like the logistics chain that delivered fuel and ammunition to English airfields. The Mustang gets the glory, but the paper tank deserves more recognition. It was the unsung enabler, the force multiplier hiding in plain sight. Speaking of logistics, let's appreciate for a moment how insane the scale of American war production was. In 1944, the United States produced 96,318 aircraft. That's not a typo. Nearly 100,000 airplanes in 1 year. That's 264 aircraft per day. One new plane every 5.5 minutes, around the clock, all year. And that's just aircraft, not counting tanks, trucks, ships, guns, bullets, bombs, uniforms, boots, rations, radios, and everything else needed to fight a two-ocean war. American industrial capacity was the secret weapon of World War II. Germany and Japan never had a chance once that capacity was fully mobilized. They could win early battles through superior tactics and training, but they couldn't match American production. Every German fighter shot down was replaced more slowly than the Americans could produce new bombers and escorts. Every Japanese aircraft carrier sunk was irreplaceable, while American shipyards churned out Essex-class carriers like automobiles. The paper drop tank fits into this industrial story perfectly. It represented American ingenuity, solving a resource constraint through innovation rather than brute force. Instead of demanding more aluminum, someone asked, what else could work? And found an answer. This is what nations with robust industrial bases and innovative cultures do. They adapt. They improvise. They find the edge cases and exploit them. Germany, by contrast, was increasingly locked into resource scarcity. Their fuel supply was under constant attack. Their aluminum production depended on bauxite from occupied territories. Their ball-bearing plants were bombed repeatedly. Every resource constraint narrowed their options. They couldn't afford to be wasteful or experimental. The paper tank was a luxury of abundance. America could afford to try weird ideas because failure wouldn't be catastrophic. There's another dimension to this story that deserves attention, the human dimension. We've been talking about aircraft and tanks and production statistics, but let's not forget that every P-51 had a pilot, and every bomber had a crew of 10 young men whose lives depended on those escorts showing up. The bomber crews called the fighters little friends. When you're a B-17 waist gunner watching a swarm of FW-190s tear into your formation, the sight of P-51s diving to intercept is literally life-saving. Crews tracked fighter escort schedules obsessively. They knew the fuel ranges and calculated how far into the mission they'd be covered. The extension of fighter range meant the extension of that protective blanket, fewer hours of unescorted terror, better odds of coming home. I've read first-hand accounts from bomber crews describing the moment they realized the escorts weren't leaving. Missions in early 1943, the fighters turned back at the German border. Missions in mid-1944, the fighters stayed with them to Berlin and beyond. Grown men wept with relief. They understood, viscerally, that their survival odds had just improved dramatically. For fighter pilots, the long-range missions presented both opportunities and challenges. Opportunities because there were targets everywhere the Luftwaffe was being forced to fight, and every fight meant potential kills for aggressive pilots building their scores. Challenges because the missions were exhausting. A round trip to Berlin and back might take 7 hours, much of it spent at high altitude in an unpressurized cockpit, breathing oxygen, maintaining formation, scanning the sky for threats. The cold was brutal. The concentration required was immense. In combat itself was a few minutes of absolute chaos, violent maneuvering, split-second decisions, life and death determined by a quarter-inch of deflection on a gun sight. After a mission like that, pilots were drained. Many slept for 12 hours straight. Some developed stress disorders that we now recognize as PTSD. The physical toll of sustained operations was significant, but they kept flying because the mission mattered, because every German fighter destroyed was one that wouldn't be. Attacking American bombers. Air superiority was the prerequisite for everything else. D-Day, the liberation of Europe, and the final destruction of a Nazi regime. These pilots weren't abstractions. They were young men from Texas and Ohio and California, most of them in their early 20s, doing a job that required extraordinary courage and skill. And they were enabled, in part, by paper tanks bolted to their wings. Let me address something that history buffs might be wondering. Specifically, deserves credit for the paper drop tank innovation. This is where the historical record gets murky. Multiple individuals and organizations contributed to the development and deployment of paper tanks. The British had experimented with composite drop tanks early in the war. American manufacturers developed their own processes. Government agencies, military procurement offices, and private contractors all played roles. Unlike, say, the invention of the airplane or the development of the atomic bomb, there's no single inventor whose name is universally associated with paper drop tanks. Part of this is because the innovation was evolutionary rather than revolutionary. The underlying technologies, phenolic resins, paper lamination, and composite materials, existed before the war. Applying them to fuel tanks was a matter of engineering adaptation rather than fundamental discovery. The real innovation was organizational, convincing a skeptical military establishment to try an unconventional solution, proving the concept through testing, scaling up production, and integrating paper tanks into operational doctrine. This kind of innovation is collaborative, distributed, and hard to attribute to individuals. What we can say is that the decision to pursue paper tanks reflected a particular problem-solving mindset, one that prioritized pragmatic solutions over doctrinal purity. Some engineer or logistics officer looked at the aluminum shortage, looked at the fighter range problem, and made the lateral connection. Paper can hold fuel. We have paper. Let's test it. That's the kind of thinking that wins wars. Not genius-level invention, but practical creativity applied to pressing problems. And importantly, that idea had to navigate institutional resistance. It had to find sponsors within the military bureaucracy who would champion it. It had to survive the objections of traditionalists who said it wouldn't work. The fact that paper tanks made it from concept to deployment speaks to both the quality of the idea and the organizational capacity of the American war machine to evaluate and implement unconventional solutions. Contrast this with German innovation during the same period. Germany produced remarkable technologies, jet aircraft, ballistic missiles, and advanced submarines, but often failed to integrate them effectively into the war effort. The Me-262 jet fighter could have been a war-changing weapon if deployed properly, but Hitler insisted on using it as a bomber, wasting its air superiority potential. The V-2 rocket consumed vast resources that could have built thousands of conventional fighters. German engineering culture prized revolutionary breakthroughs over incremental improvements. American engineering culture, shaped by industrial pragmatism, was better at solving immediate problems with available resources. The paper drop tank is a perfect example. It wasn't glamorous. It wasn't a technological leap. It was a clever adaptation that addressed a specific bottleneck. That's the kind of innovation that actually wins wars. Let's also consider the enemy perspective. What did the Luftwaffe think about these developments? By late 1943, German pilots were noticing that American fighter escorts were staying longer. By early 1944, they were appearing over targets that should have been beyond escort range. The intelligence assessment took time to catch up, but eventually, German commanders understood what was happening. American fighters had achieved unprecedented range, and the comfortable free zone, where bombers could be attacked without interference, was shrinking. The Luftwaffe tried to adapt. They concentrated fighter forces for massed attacks that could overwhelm escorts. They developed tactics to split American fighter formations and isolate elements for destruction. They deployed newer, higher-performance aircraft like the Focke-Wulf Ta-152 and ultimately the jet-powered Me-262. But none of it was enough. The fundamental equation had shifted. Germany couldn't produce fighters and train pilots fast enough to replace losses. Each major air battle bled the Luftwaffe further. American losses were painful but sustainable. German losses were catastrophic and cumulative. Some Luftwaffe pilots have left memoirs describing the desperation of late-war combat. Adolf Galland, one of Germany's most famous aces and a senior Luftwaffe commander, repeatedly warned Hitler that the fighter force was being destroyed. He was eventually relieved of his command position for his blunt assessments. Johannes Steinhoff, another ace who survived the war, described how experienced pilots were being killed and replaced with inadequately trained youngsters who became easy prey for American fighters. The quality of the Luftwaffe declined even as the quantity of American air power increased. It was a death spiral with no way out. And the paper drop tank, by enabling American air power to project farther and stay longer, accelerated the spiral. Here's a counterfactual worth considering. What if paper tanks hadn't worked? What if the material science had failed and the tanks leaked or disintegrated in operational conditions? The aluminum bottleneck would have remained. Metal drop tank production would have been constrained. the Mustang's effective range would have been limited. Bomber losses would have continued at unsustainable rates through early 1944. The air superiority campaign might have stalled or failed. Without air superiority, D-Day becomes much more difficult. German aircraft attacking the invasion beaches, interdicting supply lines, striking naval forces, the Normandy campaign could have turned into a bloodbath even worse than it was. The entire timeline of the European war might have shifted. Liberation of France delayed. More months of Nazi occupation. More death camps are operating. More civilians are dying. I'm not saying paper tanks single-handedly won World War II. That would be absurd. Countless factors determined the war's outcome. But the paper tank was a link in a causal chain. Remove it, and the chain weakens. Maybe something else fills the gap. Maybe metal tank production increases despite constraints. Maybe the air war follows a different path to the same destination. But maybe is doing a lot of work there. In actual history, paper tanks existed, worked, and contributed to victory. That's the reality we have. Let's shift to the post-war legacy. After 1945, the paper drop tank largely disappeared from military use. Aluminum became plentiful again. Jet aircraft with much higher fuel consumption required larger, more robust tanks. The specific conditions that made paper tanks valuable material. Shortages, propeller-driven fighters, and the particular demands of the European air war faded into history. Modern drop tanks are typically made from aluminum, composites, or specialized plastics, engineered to withstand supersonic speeds and the extreme conditions of contemporary combat aviation. But the concept that paper tanks embodied using unconventional materials to solve logistical constraints remains relevant. Military innovation continues to grapple with resource limitations. How do you project power when supply chains are stretched? How do you manufacture equipment in austere conditions? How do you achieve capability without critical materials controlled by adversaries? These questions drive research into alternative manufacturing, 3D printing, local production, and expedient engineering. The spirit of the paper drop tank, pragmatic, resourceful, unbounded by conventional thinking, lives on. There's also a broader lesson here about the relationship between innovation and institutions. The paper tank succeeded because the American military, despite its institutional conservatism, had mechanisms for evaluating unconventional ideas. Testing protocols, pilot programs, feedback loops. An idea could emerge from anywhere a contractor, a field commander, an engineer, or research lab, and find a path to implementation if it proved effective. This wasn't automatic. Many good ideas died on the vine due to bureaucratic resistance or lack of sponsorship. But the system was porous enough that some innovations got through. Comparing this to other military institutions is instructive. The Soviet Union had tremendous engineering capability, but was often hamstrung by political interference and ideological rigidity. Nazi Germany had brilliant engineers, but lacked the organizational coherence to prioritize effectively. Imperial Japan had innovative aircraft designers, but couldn't match American production or pilot training. America's advantage wasn't just industrial capacity. It was the institutional flexibility to harness that capacity effectively. The paper tank was one small demonstration of that flexibility. Now let's bring this story full circle. We started with bombers getting slaughtered over Germany. We traced the problem to the fighter escort range. We identified the solution, drop tanks, and the obstacle, aluminum shortages. We met the unconventional answer, paper tanks, and followed them through skepticism, testing, and deployment. We saw how they enabled the P-51 Mustang to escort bombers to Berlin and back, how they contributed to the destruction of the Luftwaffe, and how they helped win air superiority that made D-Day possible. And we reflected on the broader lessons about innovation, materials, institutions, and the messy reality of how wars are actually won. What began as an absurd-sounding idea, fuel tanks made of paper, turned out to be a crucial piece of the Allied victory. Not the only piece, not even the most important piece, but a piece that mattered at a moment when it was desperately needed, and that worked when experts said it wouldn't. This is how history actually happens. not through grand strategies executed flawlessly, but through countless small decisions, improvisations, and innovations that accumulate into victory. The general who changed escort doctrine. The engineer who tested paper composites. The factory worker who laminated tank components. The crew chief who mounted tanks on a Mustang's wings. The pilot who flew the mission. Each contributed something. None was individually decisive. Together, they built a system that destroyed over 5,000 German aircraft and helped end the deadliest conflict in human history. And it started with someone asking a question that everyone else thought was stupid. What if we made them out of paper? That question saved thousands of lives. It shortened the war. It proved that innovation can come from anywhere, that expertise can be wrong, and that unconventional thinking matters. The paper drop tank isn't famous. It doesn't have monuments or museums dedicated to it. Most people have never heard of it. But quietly, hanging under the wings of those beautiful P-51 Mustangs, it did its job. It held the fuel. It extended the range. It got the fighters to Berlin. And then it tumbled empty through the sky, discarded and forgotten, while the Mustangs went on to make history.